This is your theta. So we use the cosine law, no? This one. Take note. This was came from this formula. Take note, we try to find out theta, which is on the figure, which is this one here. This is theta. So opposite to that is the side that you need to place here because you want to find this theta here. So by cosine law, you need this side because that opposite to this side is actually the theta which you are going to find out. So that's why here it is equated to 120 squared equals d1 squared, the remaining sides, d1 and 250, then cosine. Then by algebra, you transpose this one on the other side here to become positive, and the rest, and this 120 transfer on the other side, that's why minus by way of algebra. Then come up with the equation, and this is your theta equivalent to. Take note that this sub 1 is already known, which is 358.9728739 newtons. Next, going back to the figure now, we're done to having this angle. Now we need to find out this angle too, because once we know this angle, okay, once we know this angle, this is this angle here, okay, this angle is just equivalent to this angle. We will try to call this as theta sub 1. This must also be theta sub 1. Right? Okay. So we need to find theta sub 1. How? Theta sub 1 is the sum of the interior angles here. We have 150, we have 9.62. So all we have to do is to get theta sub 1 is to get to subtract the sum of these two angles here, 150 and 9.62. Get the sum of this, then subtract it from 180 to come up with theta sub 1. So solving it now, theta sub 1 is just equivalent to 180 minus the sum of 150 and 9.62. Where is that 9.62? Actually, that's the angle of this. So plus theta. So take note that this angle is denoted as theta. Okay. So your theta sub 1 will be equals to theta sub 1 here. But this is theta. Okay. This one, this is only theta. Okay. I hope it is clear. Okay. So this is only theta. And this is with a subscript. So that is different, huh? This is theta, this is theta sub 1, which they are not of the same value. Your theta has a value of 9.62. Your theta sub 1, okay, your theta is 9.62. Your theta sub 1 is actually here. That's why you need to get this one. So solving for, since theta is known because of this, so we can solve for theta sub 1, which is now equivalent to 20.37821973 degrees. Okay. Now, after finding theta sub 1, notice you need to solve for this sub 2. Okay? We're true on this. This is theta sub 1. Okay? This is your theta sub 1. Right? You know very well that this is 90. This is actually the 200, and the entire of this is actually 300. Okay. Again, this is 200 plus this 100, so the entire going back here is actually the 300, which is parallel to this side. So first we go to the second parallelogram. The second parallelogram is actually this one. Since we were able to find d sub 1 here, so the second parallelogram will be considering your d sub 1 now, which is parallel to this side, and then with this 200 parallel din dito. So this now determine this side and this side is now your second parallelogram, and then we need to solve for d sub 2. Okay, so this is now the d sub 2. So take note for this, we can have it this triangle analyzed. So we know that this angle will have how much? We will call this as your theta sub 2. Okay, theta sub 2 is the purpose to find out theta sub 2 is to solve for d sub 2. Since this is known, this is also known, which is 200, which we took this from this side parallel to that, so therefore this is 200. So we can get this theta sub 2. How? Since this is 90, so this is 90 now, this one, so plus theta sub 1 is actually your theta sub 2. So solving now theta sub 2, okay, your theta sub 2 is equal to 90 plus theta sub 1, which is now equivalent to 100